Hey guys, welcome back to my channel, The Math Pat, and today we're going to do some advanced questions for Surds. If we look at the first question, it says root of 5 is being multiplied with root of 8 plus root 18, and we have to rewrite this in the form of a root 10, where a is an integer. So as you can see, we're going to expand brackets first. Expand the brackets, we're going to multiply root 5 with root 8, and then root 5 with root 18. So when you're multiplying roots, we can combine them under one root and write it as root of 5 times 8 plus root of 5 times 18. Now we know 5 times 8 is 40, and 5 times 18 is going to be 90. Since we have to write in the form of a root 10, it means that inside the root, we need to have number 10. So 40 can split into 4 times 10, and 90 can be split into 9 times 10. And since 4 and 9 both are square numbers, 4 comes outside as 2, and 9 comes outside as 3. So that's going to be 5 root 10, which shows a is 5. Question 6 says show that 4 minus root 3 times 4 plus root 3 divided by root 13 simplifies to root 13. If you remember the rule difference of perfect squares said a square minus b square is the same as a minus b times a plus b. Difference of perfect squares. So which means we can rewrite 4 minus root 3 times 4 plus root 3 as 4 square minus root 3 whole square over root 13. Basically 16 minus 3 is 13 over root 13. Next, what we do is we rationalize the denominator. So what we do is we multiply and divide the fraction by root 13, which gives us 3 root 13 over square of root 13, which is 13 root 13 over 13, and root 13 is our answer, which is the same as what they were asking for in the question. Question 7, it says express root 3 plus root 12 in the form of a root 3. So root 3 shows 3, and 3 is already a prime factor, so we cannot further break it down. However, 12 is it's a composite number, it's not a prime number. So which means we can split 12 into 4 times 3. And the reason why I chose 4 times 3 is because in the question they're asking us to give 3 in under the root, not some other number. So just directly go for 4 times 3. We know 4 is a square number, so 2 comes outside. Now we can combine the roots, and that gives us 3 root 3. If you've noticed, when we're adding or subtracting roots, we need to make sure that the number inside the root sign is the same. However, when we're dividing or multiplying, it's not necessary to have the same number inside the root sign. In the next question, it says express 1 over root 3 whole power 7 in the form of square root of a over c, where b and c are integers. So we know 1 to the power of 7 is 1, and square root 3 to the power of 7 will be as it is. Next, what we do is we're trying to get rid of the root from the denominator. So in order to do that, what I'm going to do is I'm going to multiply this by root 3. When you multiply this by root 3, we get root 3 over root 3 whole power 7 times root 3. If you remember your rules of indices, root 3 whole power 7 is basically 3 to the power of 7 by 2, and root 3 is 3 to the power of 1 over 2. So if we combine this, that's going to give us 3 to the power of 7 over 2 plus 1 over 2. Once again, rules of indices. If similar bases are being multiplied, we add the powers. That's going to be 3 to the power of 8 over 2, which is 3 to the power of 4. And 3 to the power of 4 is 81. So B is 3, C is 81. Question 8 says rationalize the denominator. So previously when we were rationalizing denominators, in the denominator we only had like one term, which was like for example root of 2 or root of 13 or any number. But now what's happening is that in the denominator we have like something either being added to the root or the root being subtracted from a number. It's slightly different. So in such cases, when we're trying to rationalize the denominator, we multiply the numerator and denominator by the conjugate of the denominator. So conjugate will be, for this case, 7 plus root 5. So what's basically happening is that in the conjugate, your middle sign changes. So if it's originally positive, then it becomes negative. If it's originally negative, it becomes positive. So in this case, what we do is we multiply the denominator and the numerator by the conjugate of the denominator. So that is 7 plus root 5. That's going to be 4 times 7 plus root 5 over 7 minus root 5 times 7 plus root 5. Now, if we notice in the denominator, it's basically the difference of perfect squares. If I highlight this over here, a minus b times a plus b equals to a square minus b square. We're literally applying the same rule. So what we can do is we can rewrite the denominator as, firstly we can, expand the brackets in the numerator. So that's going to be 28 plus 4 root 5. And the denominator, we can write it as 7 square minus root 5 whole square. So 28 plus 4 root 5 over 49 minus 5. So 28 plus 4 root 5 over 44. And if we split the fraction to like two fractions, 28 over 44 plus 4 over 44 root 5. So that's going to be 7 over 11 plus root 5 over 11. That is your answer in its simplest form. Similarly, if you look at question number 9, it's asking us to express 3 over 2 minus root pi in the form of a plus b root pi over c minus y, where a, b, and c are integers. We're going to repeat the same steps. We're going to multiply and divide the fraction by the conjugate of the denominator, which is going to be 2 plus root pi. will be 2 plus root y. That's going to give us 3 times 2 plus root y divided by 2 minus root y times 2 plus root y. That's 6 plus 3 root y divided by 2 square minus root y whole square. Once again, we're going to apply difference of perfect squares in the denominator, which will give us 4 minus 5. So as you can see, A is 6, B is 3, C is 4, and the placement of y is exactly the same. Question number 10 says, without using a calculator, rationalize the denominator. It's the exact same thing. We begin with multiplying the fraction and dividing the fraction by the conjugate of the denominator, which in this case is 3 plus root 7. Multiply the numerator and denominator to each other, so it's going to be 6 times 3 plus root 7 over 3 minus root 7 times 3 plus root 7. That gives us 18 plus 6 root 7, and the denominator will be 3 square minus square root 7 square. 18 plus 6 root 7 over 9 minus 7, which is 2. Since it says simplify your answer, so we split it into two fractions, and 18 over 2 plus 6 root 7 over 2, which is 9 plus 3 root 7. If you want to, you can take 3 common, and it's going to be 3 plus root 7. But either way, it's the same thing. That's your answer. Question 11 says, show that root 8 over root 8 minus 2 can be written in the form of n plus root n. So once again, same steps. Multiply and divide the fraction by the conjugate of the denominator. This is going to be root a plus 2 over root a plus 2. Multiply the numerator to the numerator and denominator to the denominator. So that's going to be root 8 whole square plus 2 times root a whole square minus 2 whole square. 8 plus 2 root a over 8 minus 4, which gives us 4 in the denominator, which is 2 plus 1 over 2 root 8. Now, n outside and inside the root, so they're representing the same value, which means we can prime factorize root 8 into 2 root 2, which equals to 2 plus root 2. That is your answer. If you have any questions or confusions about any of these, just let me know in the comments below and I'll help you out.